All right, so we're going to talk today about force diagrams. And force diagrams are pictures that we draw that visually represent forces acting on an object, right? And they consist of two basic things, a circle and some arrows, okay? And the number of arrows depends, because for each force that is applied to the object, you draw an arrow. So if there's two forces, there's two arrows. If there's seven forces, there's seven arrows, and so on. All right, so the other thing you need to know is that forces have two main components. They have direction and they have magnitude. Magnitude is a fancy word we use to mean strength. We're going to wait just a second for Jared. Hey, Jared, how you doing?
Good.
Good. We are just started our little mini lesson. Okay, we're talking about force diagrams or vectors. Sometimes they're called vectors. And so a force diagram has a circle and some arrows, as many arrows as there are forces. And forces have two things, two main components, direction and magnitude. Direction is pretty easy, up, down, right, left, north, south, whatever. And magnitude is just another way to say strength, all right? So the arrow points the direction the force is applied in. So if you look at these two force diagrams, those forces are applied down, okay? Now, my question is, which one shows a stronger force, the one on the left or the one on the right? Mikey, why don't you tell us which one?
The left.
The left, right, because the arrow on the left is longer. That means it has a stronger force. Now, forces are measured in units called newtons, okay? And so, because this arrow is longer, we might say this has a force of 10 newtons, and since this arrow is shorter, it may have a force of 5 newtons, okay? So sometimes we will label force diagrams, and when we label them, what we mean is tell me the numbers that go with each arrow, okay? So far, so good?
Mm-hmm.
Very good. So if we look at this next one, okay, this force diagram has two arrows in it, so there are two forces acting on this object, and we could make up a little story about it. We could say that two people are playing tug of war, and somebody wins, right? Team A wins the tug of war match. Now, if Team A wins the tug of war match, which side of this circle represents Team A? The side on the right or the side on the left? Jared, go ahead.
The side on the left?
The side on the left, it represents the winning team.
Oh no. I'm in the side on the right. The side on the right.
Yes. The side on the right represents the winning team because it's the stronger force. It's got a longer arrow. The number is bigger. Okay, so we could come up with any number of scenarios, which are those little real life stories we talk about with things, okay, to match this. Like two people are fighting over a pencil or whatever, right? Or you're pushing an object across the floor, and so your force might be 20 newtons, your force might be 200 newtons, and the force of friction between the box and the carpet might be 20 newtons. Right? Does that make sense?
Yes.
This object is going to move. Which direction is it going to move in, Mikey?
I'm sorry.
Just throw out a guess. It's all good.
Right.
Yeah, it's going to move to the right. Okay, so if I put my hands together like this and I push harder to the right, my hands are going to move to the right. If I push harder to the left, my hands are going to move to the left. But if I push with the same force, doesn't matter how hard I push, but if both hands are applying the same force, it doesn't move, right? And so that's how forces work. The stronger one pushes the object in that direction. If they're equal, it just stays still. Now, sometimes with these force diagrams, we're going to ask you to calculate the resulting force. All right, the result for this one, because our forces are in opposite directions, we are going to subtract them to get the resulting force. So you can see down here, I typed out the resulting force equals 200 newtons minus 20 newtons, and that equals 180 newtons to the right. And we always put the direction of the stronger force. If these were equal, these arrows were the same length, we could still do this, like if they were 20 and 20, you could still say 20 newtons minus 20 newtons, and you would just say equals 0 newtons. And then sometimes you might have to say no movement or something like that, but there's no direction when the forces are equal and opposite. Okay?
Okay.
Okay. Now, does everybody feel good about this so far?
Yes.
Very good. So on the next one, I have a little scenario, and we're going to draw the force diagram. It says Joe and Bill are pushing a cart down the hallway. Joe applies a force of 15 newtons, and Bill applies a force of 10 newtons. Now, so we're going to draw a force diagram. So we're going to start with a circle. Okay? And in this case, what does that circle represent?
The cart?
The cart. Very good. Was that you, Mikey?
Yeah.
Great job. It is the cart. Now, Jared, how many arrows is this force diagram going to need?
2.
Two.
2.
2. Are they going to be the same length or different lengths?
Different lengths.
Very good. So, are they going to go in the same direction or different directions?
Different directions.
Different directions. So, you think we're going to take an arrow here and then an arrow here, right? And that shows 2 people pushing a cart down the hall?
Oh, no.
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 What do we have to do, Jared?
Flip them around.
Yeah, so they've got to be going the same direction. Very good. So I think the easiest way for me to do this is delete that arrow and draw a new one like this, right? Now, with force diagrams, when forces are going in the same direction, you can put them on different sides of the circle so they're both pointing to the right. They could both be pointing to the left because the scenario is not specific enough. The other thing you could do and make it okay is that you could put them on the same side. Now, when you put them on the same side of the circle, you want to line them up like that, okay? What would be wrong is if you put them on the same side of the circle and you stacked them. See how these are stacked? That's not good, okay? We need them lined up like that or like that, and both of those would consider correct in this case, right? Now, the next thing we should do is label this diagram, which means we need to type out how many newtons each arrow represents. So it's 15 and 10. Okay. Now, if we wanted to calculate the resulting force, all right, how would we do that in this case? So last time on the previous slide on here, we subtracted them because they were opposite. Now they're the same direction. So what do you think we're going to do with these forces? Will we still subtract them? What do you think?
Add them.
You don't know? Jared, what do you think?
Wait, can you restate that again, please?
I sure can. Are we going to add to find the resulting force? Are we going to add them or subtract them?
We're gonna add them.
We are going to add them, and the reason we're going to add them is because they're in the same direction. So these two forces are working together, right? We have a name for that as cooperating forces. So with cooperating forces, we add them together to get the resulting force. So it's 10 newtons plus 15 newtons. And that equals 25 newtons. And then we should have the direction there. In which direction are these arrows pointing?
In.
To the right.
I mean, to the right. Yeah.
Yep, it's okay. It's our first one. It's all good. So that's 25 newtons. Oh, that should be equals. 25 newtons to the right. Right? Okay. So when they are in the same direction, you add them. When they're in opposite directions, you subtract them. If a force is stronger, you make the arrow longer. Okay. Always one circle and as many arrows as you have forces. Okay? Does that help kind of make this make more sense?
Yes.
Now you're going to use this information